So this is the Edexcel Further Pure Maths Paper 2R. Now what the R means, and I had to look this up, is it stands for the regional paper. Now because this is an IGCSE, it's taken all around the world, you can't just give everyone exactly the same paper at the same time, because it's not the same time for everyone. People in Australia will take it much earlier, and then therefore people who live in later time zones could cheat because they would know what's on the paper. So this R stands for the regional paper that's given to the Far East, Australia, or the Asian countries and so on, whereas the papers that don't have an R on were given to the Western world, Americas and Europe and Africa and stuff like that. So yeah, that's kind of interesting. It doesn't really matter though to anyone taking this because the two papers are pretty similar. They just ask different questions, obviously, and so whichever part of the world you're in, you should just be practicing on all the past papers you can, not just the ones that are that would have been given to your time zone, because it doesn't really matter. So anyway, let's get into it. This is paper 2. It's calculator, which I'm going to complain about at some point, probably pretty soon. Given f of 0 is this, so we put 0 into here, and yeah, turns out fairly straightforward. You just say that makes it minus 12, and this all just goes away here, and you just end up with q is 4. Good. Find the range of values for which this only has one real root. Now, we know f of x, this is f of x, we can put the 4 in now. We know it has one root at x equals 3. Like, it just does. So for it to only have one root, it means this quadratic here can't have any roots. And if it doesn't have any roots, then that means its discriminant is less than 0. So its b is p minus 2, its a is 1, and its c is 4. So we want b squared minus 4ac to be less than 0. You could expand this out. I think I'd do in a second, but I did this the cheap way first. I just put the 16 on the other side, square rooted, and said either this thing is less than 4 or it's bigger than minus 4. Because things bigger than minus 4 will square to positives but less than 16 until you get up to 4 itself. And then of course p is less than 6, p is greater than 2, which gives you this single thing. If you're more comfortable, you can expand this thing out and then refactorize, and you'll get your two critical values, and you need to be in between them. So in between minus 2 and 6, which is what I've said here. Doesn't really matter. But anyway, question number 2. So we get a nice graph here. This is called a rational function, in case you don't know, because it's described with polynomials that are rationally about 1, like it's a ratio. So it's a rational function. It's given you a bunch of asymptotes. I'm going to ask you to work out these things. So what this first thing tells us is that when y is minus 2, there is no x solution. So if you put in minus 2 into this, like x doesn't equal any, you can't solve for x, which seems a bit weird at first, but it makes sense when you cross multiply and then go, okay, well, if a was minus 2, then minus 2x would cancel with minus 2x, and you'd have to have c equal to b, which could be the case, but it's the only way that you're not going to have a solution at all. Like if a was anything other than minus 2, like minus 1, then it doesn't matter what c and b are, you'd always find a solution. The only way you can't find a solution is if a is minus 2 and this cancels with this, and that's not equal to that, which we'll find out later that it isn't. The other way to think about that is, like, if you put in x is like a really, really, really big number, you essentially have y is equal to minus 2, and when you put in x as a massive number here, these two numbers, assuming that they're not that big, or even just putting in an even bigger value for x, these kind of things don't really matter, and you just get a, or ax over x, which is just a, so minus 2 just equals a. No matter how you want to think about that. That's probably the most difficult one to figure out. The rest of it's a bit easier. Here, again, an asymptote at x equals minus 3, so when x is minus 3, there's no solution to y, so we put minus 3 in as our x values. I've also put in the a value as minus 2 here. And now, does this not have a solution? Well, it's only if you can't divide by 0. So if this bottom bit is 0, y doesn't equal anything. So if c was 3, this just doesn't really work. So that's going to be our value for c. It crosses 4, 0, so when x is 4, y is 0. If we just put those two values in, and now knowing that our a is this and our c is that, we end up with, well, it doesn't really matter actually what c is here, because we just need this thing to be 0. And so b is 8. And that's basically all we need, because now we've got the formula for the thing, and now we say, well, when x is 0, y is p, put those in, and you just get p is 8 over 3, which is a rational number, which is good, so that's going to be the whole thing. Question 3, they really like questions like these. I don't really understand, because for me it's like one of the most boring bits of A-level maths, actually it's A-level further maths, isn't it? No, I think it is just regular A-level maths. And I don't understand why you would choose this to bring down into GCSE as your thing, when you've got lots of other choices that are slightly more interesting. But anyway, I'm complaining, aren't I? You'll see a lot of that later on in the paper as well. So we've got the diameter of the rod is this. The rod's being heated, so the length of the rod is increasing at a rate of this. So dl, if I call the length L, dl by dt is this. Okay. Now find the increase of the volume the rate of increase of the volume when x is 3. So we're looking for dv by dt, that's the rate of increase of volume when x is 3. So I need to find dv by dt in terms of x, and then I need to put that value 3 in. Now I can find dv by dx because of course the volume of this rod is pi r squared times the length, so that's pi times x over 2 squared, or squared, be careful, times the length, which is 10x. Simplify that down and you get this, and of course you can differentiate that, so dv by dx is this, just timesing by 3 and then bringing it down. Now, the way that these questions usually work is you say, well, I want dv by dt, so I'll say dv by dx times dx by dt is that, because essentially these dx's cancel and you just end up with dv by dt. Now I have this, that's good, but I don't have this. Like I have this thing, but this is where I go back to the start and go, well actually, instead of just calling this a length, call it 10x. So d of 10x by dt is the same thing, but of course the 10 can just bring out to the front, and we just get this. And then divided by 10, we get that, and then this can go into here along with this, and we'll evaluate that when x equals 3, and we'll get our answer to 2 significant figures. Question number 4. So I always think of this as a ladder. This is classic mechanics A-level. You've got displacement, velocity, then acceleration going down. Displacement, velocity, acceleration. You differentiate to go downwards, you integrate to go upwards. So if you've got the acceleration in terms of t, I need to integrate to find the velocity. I'll integrate it then, that's with a plus c, remember, but it says when t is 0, the velocity is 0. So when t is 0, v is 0, which means c is 0, so that's just the function for v. Put in time as 2, and we work out our answer there. Here it's at rest, so v is 0, so we just say v is 0 and solve for t. Divide by 3, because that's always a good idea. It wouldn't have really made a difference there, and you get these two answers. But t is bigger than 0, so t must be 4, is the one they're looking for. Find the distance traveled. Now, there's a trick to this question, which is having to think about what you're doing here. Now, again, I mentioned that ladder, displacement, velocity, acceleration. So we need to integrate again to get to displacement or distance. So we need to integrate this function. So let's do that. So it seems obvious this will be what we have to do. Integrate the velocity between 8 and 0 for the first 8 seconds. Now the problem is, think about what this actually looks like if you were to graph it. And part B gave you a massive hint here. But the velocity itself is a quadratic, right? And it's a quadratic that has roots at 0 and 4. So it looks like this. Now, if I integrate that between 8 and 0 in one go, this area is going to cancel a lot with this area. And so my answer won't be the distance. Distance is just a raw number. So distance isn't quite equal to displacement. This is true for the displacement, but displacement counts, if you walk 1 meter forward and then 1 meter back, your displacement is 0, but your distance is 2 meters traveled, right? So to find the distance, we actually need to integrate between 0 and 4, and then add the integral from 4 to 8. So this will be, maybe I should have changed this to a d now for distance rather than displacement, because that's what I've just said. We're actually working out the distance now. Do that integral, put in all the numbers very carefully. Of course, you've got a calculator, so you can just sub them straight in, and we get our answer of 192. But yeah, quite an interesting trick to that question. Quite early on in the paper to be doing those tricks as well. But anyway, one of the reasons that I did this first time correctly was because I've seen other past papers of this paper. And so I've seen this trick before, and again, that's just why it's so important to do past papers, because you see the tricks that they like to use, and then you won't be caught out by them again, hopefully. Okay, so draw these lines onto this grid, easy, so let's rearrange and divide by 3, and we'll get this. So this has y-intercept of 8 and a gradient of -2/3, so every 2 it goes down, it runs across by 3, so it goes from here to here and then keeps going through that line. This y equals 2x, of course, 2 across 1 up. 1 across 2 up, I should have said. So 0, 0, because the y-intercept up to 0, and then up to there. So that's that one. And this one, just divide by 3, has a y-intercept to -4. This one's quite annoying to plot because you can't put the y-intercept down. What I ended up doing was just putting in quite a large value of x. So if you put in x as 6, 2/3 of 6 is 4, take away 4 is 0, so you know it goes through 6, 0. And then you can do the rise over run. So it goes up 2 for every 3 it goes across, so it goes through there, and that'll be the answer. I stared at this for another minute because I was convinced that it just doesn't look like the usual things that they give you. But anyway, r is defined to be below this line, below this line, below this line, below this line, and above this one. So it must be this region here, and above, the y equal to 0. So above this one is here. So this is r. and find the maximum value of f if this is true. Now, the way that I thought about this was, firstly, I'm quite comfortable just doing lots of trial and error, and that's what I end up doing. But like, okay, so you want x and y to be as big as possible, obviously, but really you want to prioritize y because that's being times by 5 rather than 2. So if I start with this point, say, which is the 0.36, and just put that in. Now, I'm trying to make y as big as possible again because it's being times by a bigger number. So when you put in that in, you end up getting 36. And what I thought was, okay, what if I just kind of, moving down this line is completely pointless. Because if you move down this line, you're making both the y and the x coordinates smaller. Like you're going from 3,6 down to 2,4, and making them both smaller is pointless. Moving down this line, though, you make the x coordinate bigger, right? You're making the y smaller, but you are making the x bigger. Now, I've already said that probably doesn't seem like a good idea because you want to prioritize the y, but let's just try it. Let's just try 6,4, let's say. 6,4 here. And indeed, my guess is right, it does make it smaller. So it stands to reason we're just going smaller and smaller as we go along this line. And actually, this is going to be the maximum point. The next I did try 9,2, just for the hell of it, but it makes it even smaller. I was just being very careful, but this is going to be the maximum value, and you can kind of logically deduce that, but that's going to be the biggest it can be. Again, going down this line is completely pointless because it makes both smaller, and going into the middle somewhere, again, pointless because, you know, if you start here, you're just reducing the y coordinate to go down into this section, so yeah, this is going to be the biggest one. So some binomial expansion here. So the way we do this, they want a 1 here. It's possible to just binomially expand this straight away, but not too many people teach it that way. What you want to do is factorize out a 9 from both things. Of course, root 9 is just 3, and then this can be written as the power of a half, and this we end up with as our expression here, where p and q are constants. Now it wants us to expand that, so okay, well, we just keep the 3 outside. To expand this, we just have a 1 as our leading term, which is why people like having 1s here, and it also doesn't affect any of the other terms. This term here is just a half times this to the power 1. Again, the other 1 doesn't do anything, which is why they like it. This bit here is a half times a half minus 1 divided by 2, and then you square this bit here, and the next one is a half times a half minus 1 times a half minus 2 over 3 factorial, which is 6. Times this cubed. And then the other terms don't really matter. Just type all of these things into a calculator to make sure you're getting it all right. By the way, if you're taking maths at university or have any intention of, it's massively worth trying to get good at doing this kind of thing in your head. Although I said just type into a calculator, if you're in the real exam, of course, because it's quicker and you don't want to get it wrong, it's worth practicing doing this kind of thing in your head and working out how to do this, because in university you won't be given a calculator. Anyway, that's our expression. Hence, use this with a super value of x to estimate this. Now, that means we want 31 over 4 to be this thing here. So we times everything by 4, we rearrange, and we end up with x is 4/5, which is cool. 5/4, and we substitute that into here. Just substitute in 5/4 every time, and you end up with this approximation there. I've written approximately equal to because I've got rid of these plus ... because I've reduced the expansion down because these terms aren't really going to matter because I'll be dividing by such a massive amount that it's going to be fairly negligible. Impossible word to say. Anyway, geometric series. So yeah, the first term. So geometric series starts with a, and it goes a times r is ar times another r is ar squared times another r is ar cubed, and so on. Given u to the third term, u3 is 4, so the third term is this, so that means ar squared is 4, and the seventh term is 16. Now the seventh term, notice how the third term is 1 lower in terms of the power, because it starts without a power at all, or the power 0. This is ar to the 0 technically. So the seventh term is ar to the 6. You can also count 1, 2, 3, 4, 5 with a 4 next to it, 6 with a 5 next to it, and then 7 with a 4 next to it, with a 6 next to it. Now, of course, we have this as a simultaneous equation. We can divide this by this. This divided by this is 4. This cancels with this. This gets an r to the 4. Square root gives you r is 2, and then square root again gives you r is root 2, which is what they asked you to find. It's positive, of course, because the question literally says that it's positive. Find the least value of n for which un is greater than 500. Now, just a small trick here. Just remember, un, just like u7, is ar to the 6. Un is ar to the n minus 1. By the way, I've also missed this. Of course, if r is root 2 squared is 2, a times 2 is 4, a is 2. Anyway, this bit here, we get ar to the n minus 1 is the nth term. Because, again, you reduce the power by 1. with this term number. So we're looking for this divided both sides by 2. You could be fancy here, but I just wasn't. I just took log to base root 2 of both sides, typed that into a calculator, added 1, and then of course that means the least value of n, which is greater than 517. Check that. Just check it in the calculator. Type in 2 times root 2 to the 17 and make sure that's the first thing above 500, which it is. Not to the power 17, sorry, to the power 16, because it's 1 less than it, of course. Yep. The sum of the first n terms is this. Now, in the formula booklet, it gives you the sum of a geometric series. Sorry, it's this. Now, of course, we know that a is 2. We know r is root 2. We know n is 20. So this can just all go into the formula here. It wants it in this form. Now, this is where, again, I complained at the start, this is a calculator paper. I did some really lovely maths on this to get it down to this form, which I was really pleased with. It was just some really nice maths, which I'll show you. The mark scheme just says, yeah, type that into a calculator, mate, and just get the answer, and then rationalize it, which just for me reduces the enjoyment of it. I'll show you what I did. Now, root 2 is of course 2 to the power of a half, and a half times 20 is 10, so this is 2 to the power of 10. Of course, I can expand out the 2. 2 to the power 1 times 2 to the power 10 is 2 to the power 11, of course. Now I rationalized, and of course, 1 times 1 is 1, middle terms cancel, minus 2 gives you a minus 1 on the bottom, and then 2 minus 2 root 11 plus 2 root 2 minus 2 to the power 11 root 2. Now, of course, divide by minus 1 just means all the signs swap, so I just swapped the signs and wrote it in a nice order. And then I factorized 2 to the power 11 out of the first 2 terms only, because that leaves you a 1 plus root 2, which I notice is what I kind of want. And if you also factorize out 2 from the last 2 terms, you also get a 1 plus root 2. But now, of course, I can factorize out a 1 plus root 2, and I can say this is 2 to the power 11 minus 2 times 1 plus root 2. And I don't care what this is. I know what it is because I know 2 to the power 10 is 1024, so I could work out what this is if I wanted to. But I don't care. And this is the kind of maths that I enjoy doing, and I think calculator papers reduce this kind of the necessity to do this. But I think it's really nice. And again, at university, you'll have to do things like this more and more because you don't get given a calculator. So yeah, just some nice piece of maths there. I think this is 2046 or something. I can't quite remember. You can type it into calculator and find out if you want to. Question number 8. This is a really nice question, although I don't think it was written very well. I'll explain why a bit later. Show that Bn is 5. So that's this length here. We can see if this is 10, then this is clearly 10. So this is a right-angled triangle. This is the adjacent side. So cos of 60 is this divided by 10, which means times by 10. Again, this is why papers shouldn't be calculator. We should all know cos of 60 is a half, which makes b to n 5. So yeah, again, shouldn't be calculator. I think I was just frustrated at having the other question taken away from me because the mark scheme just said type it all in. So at this point, I just kind of, for a while, I was just refusing to use a calculator and kind of just doing this. But anyway, find the length of e to n. So that's this length to this length down there. Find that length. Well, this is all about trying to make triangles as best you can. So if I drop a line straight down here and a line straight across there, I can see that, well, this length f to n, sorry, f to this point down here, oh, that isn't n, f to n is going to be the same as this. So if I work out f to n, it's the same thing as this. Sine of 60 is this over this. So it's going to be 10 sine 60, which is, well, sine 60 is root 3 over 2, times by 10 is 5 root 3. This is where I kind of refused to use a calculator for a while. That's 5 root 3 then, because it's the same as that. Then I can draw a line straight across here and say, well, that's clearly just 12. And now I can do Pythagoras to work out this distance here. 5 root 3 squared plus 10 squared, all square rooted. That's 124. 5 squared is 25, times root 3 squared is 3 is 75. And of course I can get root 219. Again, I was just refusing to do this. And I was like, nah, mate, I don't want to. Whatever this is to 3 significant figures is the answer. Part C. Find in degrees to 1 decimal place the size of the angle between BF is x, which is like halfway. What am I doing here? Oh, okay, so I copied this question up here because I need more space. BF is x, so that's kind of halfway along here. Now we worked out that this is 10, so this b to x is just a half, is 5, half of that. And we've also got a midpoint between f and c. I don't know the length of f and c, but I know that these must be the same height because of similar triangles. Because if you draw a little triangle here, and I think I'm about to, because this length is half of the whole thing, this must be exactly half of this, and likewise exactly the same argument here. This is half of the whole thing here, and because this little thing would make a similar triangle to the big triangle here, this is exactly half as well, which means these two lengths are the same, but these 2 points are exactly the same height. So anyway, I can work out this height because I can just do 5 cos of 60, or just halve this number, of course. This was 5 root 3, so this is 5 root 3 over 2. Again, if you're just working in decimals, then that's fine. I was just annoyed. Now I can do the plane. Now the angle between ABCD is the base, and the angle between AXYD is this thing. So I'm looking for like an angle. If you imagine like a plane, a sheet of paper, kind of running through these 4 points here, make a small angle with the base of the shape, and I just want to make a triangle, right? So let's just draw a line from this point, from the base firstly, which is just length 12, obviously, and then up to this point here. Or up to like any point on this line here, and you'll make this triangle. So I'm just making a triangle from this line across here, across to this point here, going up 5 root 3 and then down again, and that makes this triangle here. And I'm just looking for this like x. At this point I do need a calculator. Its tan is this over this, so the 2 times 24 times 12 is 24, and of course we get this angle here. Now part D, find in degrees the size of AYE. Now that's, if I again get rid of the clutter, y is the midpoint here, of course. So A to Y is this, and then Y to E is that. Now I can see a triangle kind of tilted within the shape like this, with a side length of 10 over there. So I thought, and I'm looking for this angle here, so I thought if I could work out this length and this length, then I can just do cosine rule backwards. So let's set out to work out this length and this length. Now there's a lot to do here, and this is why I think they could have written this question better. They could have sort of got you doing a lot of it beforehand, whereas they kind of really didn't. But we've got a lot to do here. So firstly, what I said was, well, the height up here is 5 root 3 over 2, as I've said before. Now this little length here, because way back when we worked out that this length is 5, that makes this length 3, but of course, again, as I've said, this triangle is half of the whole thing here. So if this thing is 3, then this thing is 1.5. Now that makes this length 6.5. And now I can work out this base here by doing 6.5 squared plus 12 squared, which is this, square rooted. And so that's that length. And now, of course, this length, as I've said, is 5 root 3 over 2. So now I can do Pythagoras again to work out a to y. Of course, you can just use this as the ands from before, and you get exactly root 205, which is useful because, again, I've said I want to be using cosine rule on this. So leaving my answers as surds is good because cosine rule likes squaring out the surds anyway. So that's good. And then e to y, again, it's the same kind of idea. Going to use a lot of Pythagoras to try and work out this length. So going straight across, well, that distance is clearly 12. And then if I could work out this length, then I could just do Pythagoras on that. Now, this length is of course this length, which is half of f to c. I've never actually worked out f to c at any point in this question, so that's why I'm saying part A and B should have probably been just work out f to c rather than that weird diagonal they gave you. But anyway, f to c is clearly, well, it's 5 root 3 is the height of this, plus 3 squared is the base of that, so 5 root 3 squared plus 3 squared, square rooted for this. Of course, that's root 84 if you work this out. 25 times 3 is 75 plus 9 is 84, so that's root 84, which is simplifies because of course 4 times 21 is 84, root the 4 for a 2, and that makes root 2 root 21 is this whole thing. So then you halve it to get root 21 is this half bit here, and then you do Pythagoras again to work out this length here. Of course, root 21 squared is just 21, which is why I left it as a root. And we end up with this answer here, which can go there. And now the last bit of the question is to do some cosine rule backwards to find, I'll do this fairly quickly, to find the x value in a calculator. Of course, 100 take away this, take away that is minus 270, but then you divide by minus 2, so I cancelled the two negatives. And yeah, then just typed cos inverse of that, and I got this answer here. Cool, so yeah, really long question, really well done if you did get that, because there was a lot to do there, and you only, like for me, it was easy for me to just delete all the things that I'd sketched onto the picture, but I imagine in a real exam, you know, when you get to the next part and you've already drawn all over the picture, it gets harder and harder to do anything with it. So yeah, just a really tough question that I thought. Anyway, question 9, find out region R is enclosed by the y-axis, so let's draw a picture immediately. The straight line with this equation, rearrange it, y-intercept of 13, gradient minus 2. So it goes through 13 up here, and then put in y as 0, and you get x as 6.5. So that's there, that could be helpful. X squared minus 2 is just a quadratic curve with intercept of minus 2 here. Now if I set that to be 0, I get x as plus or minus root 2, so that must be the two roots. Again, that could be helpful to me, so I'll just put that down. The region R is defined by the y-axis, this curve and this line. So the region R is actually this region here, and it's all of this. It goes below the x-axis because the x-axis isn't part of it. It's all of this region here. And they're asking us not to find that area, but to rotate that region around the y-axis and then find the volume. So what I'm going to do is I'm going to split the region into two. Again, if you've done this kind of thing as practice, you'll be used to this. Split the region in, and then this region rotated just makes a cone. Like if you just rotate this triangle here, you make a cone around the y-axis. Now that cone has radius that I need to find out and height that I need to find out, so this point seems very helpful to me. So let's find the intercept between this line and this curve here. Factorize it, it turns out to be nice. This intersect is clearly over here somewhere, I don't care about it. This is the one I want, the value 3. Put in 3 to here, 3 squared minus 2 is 7, which means this distance here is 3, and this distance here is 13 minus 7, which is 6. So this cone is going to have volume. The volume of a cone is a third pi r squared h. So r is 3, h is 6, and that's fine. Now this region here, below this, I need to integrate the curve itself between 7, which is this value here, and minus 2. So this is all I'm going to do. I'm going to do, this is, I've explained pi r squared, a third pi r squared h, that's the cone, radius 3, height 6. This bit here, of course, when you're doing a volume of revolution, you do the integral between the bounds you need, but then you times it by pi, and you do the x squared dy if it's around the y-axis. It's y squared dx if it's around the x-axis, x squared dy if it's on the y-axis. Now this is quite nice because x squared is an easy thing to get. You just add 2 to both sides, and now all I need to do is integrate y plus 2. This I already worked out as 18 pi, and now I just have an integral to do. Which, yeah, I mean, if you're used to integrals, which hopefully you are, if you're seriously taking this paper, you'll be very comfortable with what I'm doing here. I just typed it all into a calculator and I got this. Good. Question number 10, almost there. Only 2 questions left, I think. So some nice trig question here. Use the formula for, this is the whole question, I'm just going to do it bit by bit. Cos of a plus b is in the formula book, it's on the first page, it's this. So to find this, we can just set a equal to b, or b equal to a, and we get this. Of course, this is cos squared a, this is sine squared a, and this is 2a. And then, of course, sine squared a is 1 minus cos squared a. And then cos minus cos is 2 cos minus 1, and we get this here. Now this one, I'm going to do this the long way around. I'm going to say cos of 2a plus 2a, just taking this line and replacing a with 2a, I get this. But of course this is cos squared 2a and this is sine squared 2a. Sine squared 2a is 1 minus cos 2a, and then you do the same thing and you get this. Now if this was really obvious to you from this line, that's great. If you know, you can just kind of replace 2a with 4a and a with 2a, that's fine. But I just did it the long way around to get this. And now of course what I want to do is I want to say, well, I don't want cos squared of 2a, I just want things in terms of a's. So looking here, cos squared of 2a is just cos 2a all squared. So let's take this line and let's just square all of it, to square all of that, and then replace this in here. So I get 2 lots of all of this squared. Now here I'm going to have to expand brackets properly, so this becomes 4 cos to the 4a minus 2 cos squared a minus another 2 cos squared a plus 1, which makes this, and then of course expand out the brackets and simplify this up, and you get that there. Good. Part A and B I've left there just because it's helpful. Part C. This is a really nice question actually. What I'm going to do is I'm going to expand this out first to make cos to the power 4 of this minus cos squared of that same thing. And now the reason I did that is because this is now looking quite close to this with just a being this mess here. Now it's not quite right because it needs 8s here, so let's times everything by 8. And it's still not quite right because I need a plus 1 here. So let's just add 1 to both sides. And now this thing here is exactly this thing, just with a being this. So I can say all of this side here is equal to cos of 4 times that. Now, of course, this works out quite nicely because 4 times this gives you cos of theta plus pi over 6. And now, of course, you can do cos inverse over half. Principal solution is pi over 3 for that. Your calculator will tell you that. And then the next solution, picture the cos graph in your head or draw it. But cos starts positive, then goes negative, then is positive in the last quadrant. So you need to do 2 pi take away pi over 3, which is 5 pi over 3 for your second solution. Then, of course, take away pi over 6 from both, and you get your two answers just here. Yeah, a nice question. D, using calculators to find the exact value of the integral of f of a, if f of a is that. Now again, I don't want to integrate this, I want to use the thing that they've been helping me out with. Now I see that these don't quite match. So what I'm going to do is I'm going to say, well, if I halve cos of 4a, I get 4s here, which seems good, but if I halve it, I end up with a half over there as well. So I've just halved this line. I'm trying to make it match this, it doesn't quite, so what I'm going to do is I'm just going to add a half to both sides. And now I have that this exactly matches with this, which is the f of a, so now I can just integrate this thing here. So I'm going to integrate that between this and this. Of course, integrating a half is really easy. Integrating this, cos integrates to sine, and then I need to divide by the 4. If you think about differentiating this, sine differentiates to cos, but then you bring a 4 to the front, 4/8 is a half, and so I end up with this. Of course, a half just integrates to half a. Put in the two bounds. You can just type everything into a calculator. Immediately you spot that sine 2 theta is 0, so that just goes away, and you end up, if you know sine 2/3 of pi is root 3 over 2, then great, otherwise your calculator would have done it for you. Again, it's probably things that you should try and learn off the top of your head, and we end up with this, and we can simplify that to that, and that'll be our answer. Writing it in the form that they've got it, maybe put a 6th there, and yeah, who cares. Question number 11, last question about roots. So cool. So we've got our quadratic here. Now, the first thing I'll say is that alpha plus beta, which one I did first? Okay, alpha beta is q over 1, which is just q. And then alpha plus beta is minus p over 1, which is just p. So that's what I'll start with. It tells you that 2 alpha beta is 3, which means that q is 3 over 2. Because if you just times this by 2, you get 2 alpha beta is 2q, which means 2q is 3, which means q is 3 over 2. And now, what about this then? Find an expression in k and for p. Well, how do I make anything like this? Well, if I take this and square both sides, and this is just a trick that you learn every time you do root questions like this. Square both sides, expand the brackets out properly. 2 alpha beta is, of course, 3, so I'll just put that straight in there. I've put the 3 over here because this thing here looks a bit like what I want, so I'm just going to times everything here by 4. And now I can replace this thing here with k squared minus 6a minus 3, and that gives me an expression in terms of k and p, which is kind of what I want, so I want to rearrange this 4p. If I divide everything by 4, I'm not actually going to do that, I'm just going to say it's a quarter into this, but I noticed that this actually is nice because it factorizes into something that's repeated. And so because it's repeated, when I square root, I can just cancel one of these, and a quarter squares to a half, and I just end up with a half k minus 3. So quite a nice little trick there, but yeah, that will be p. Given also that this is true, now alpha plus beta is q, so this equals 7q, which apparently also equals this. And now q equals 3 over 2, so that equals 21 over 2. Now alpha beta is equal to what am I doing? Alpha beta is equal to q, so I replaced that. Q is equal to 3 over 2, so I did that. Now I can introduce this. Alpha plus beta is p, so this equals 3p. But p is this thing here, so that means I can solve for k. So I just divided by 3 to get 7 over 2, cancel the halves to get 7, and then we add 3 to get k as 10. I also said at this point, just because it's going to be helpful for the next bit, that this here implies that p is 7 over 2. So alpha beta is equal to 3 over 2, because that's what q is, and alpha plus beta is equal to 7 over 2, because that's what p is. And also, apparently this thing is true. I've just written down what we know so far in the question to see if it will help me for this. Hence form an equation which has roots this. Now there are fancy ways of doing this, but I kind of just did the brute force method. What I said was, if you know that these are the two roots, you can just factorize it to be this, x minus the first root, x minus the second root equals 0. Now I'm just going to expand everything out. X times x is x squared, x times this is minus this, and then another minus lot of that means I can factorize that out and say it's minus this plus this, lots of x, and then if I times these things together, minus times minus is plus, I just get this here, alpha times beta is alpha beta, this times this is this times this. Now the thing is though, I know lots of these things. Now, I know alpha beta is 3 over 2, I know alpha plus beta is 7 over 2, so that makes 49 over 4 when I square it, or times it by itself. And I know this thing, these got the same base here, so I can just say This is just alpha plus beta over alpha plus beta, which is of course just 1. Type that into a calculator, or learn how to do fractions over fractions, and you get this. This is of course just -1, times everything by 49, and we end up with that as our final answer. And that's the whole paper, I believe. So yeah, quite an interesting paper. Lots of little tricks in there that caught you up. I made tons of mistakes on this, so don't feel too bad if you did too, because I certainly did. Don't know whether it's just because I'm tired. But anyway, thank you so much for watching.